So you might have guessed I'm a huge fan of wind generation, but of course there are problems with wind generation. The main reason I like wind generation because the energy density is just so much more than there is in solar. Solar is something like 0.3 of a watt hour per square metre, whereas wind is something like 3 watt hours a square metre. I'm making those figures up, it's just for comparison. There's an awful lot more energy in wind if we can harness it efficiently. And of course that makes it very attractive, which is why you see wind turbines all over the place as an alternative to solar, because it's seen as the most readily available and easily accessible form of alternative power generation, and so you see them everywhere. There's lots of money being spent on them. There is of course an issue for the individual, is they're not really that amenable to micro generation, or rather they haven't been. Now another issue with wind generation is it's one of those areas that for some reason or other seems to elicit huge arguments about every single thing. So is a VAWT better than a HAWT? How about this particular blade shape? Is it more efficient than something else? And you find these massive amounts of arguments all over the place about the nature of turbines and wind generation per se. So it does elicit a lot of argument, and it does form a troubling area trying to work out what it is you can do. Now of course we've been working a lot on that, showing alternative ways of actually building these things for yourself that may or may not be more efficient, but are certainly alternative. And obviously one of the main issues I have is cost. For me, it's got to be cheap enough to build and easy enough to build so that the individual can build it. Traditionally, of course, efficient, powerful wind turbines are the provenance of electricity and generation companies. They're massive and they're hugely expensive. So it's a problem to translate that into a lower scale where we can actually do it for ourselves. And of course, we've been exploring the ideas of combined micro generation, which is what the wind wall is. The wind walls that we've been coming up with are various turbine types that are constructed in a unit where they can all work together. So it's lots of little micro generation being brought together to build macro generation. Now that's a concept, that idea of putting a whole load of little things together. Big turbines are really quite difficult to synchronise. They're very much standalone, and it's quite difficult to actually get them coordinated because of the distances that are apart. The wind can act in very different ways, and so other control systems need to be put in place to synchronise large banks of large wind turbines. Smaller banks of smaller wind turbines aren't that difficult to synchronise because the effective area the wind is acting on is, broadly speaking, the same. So it makes them slightly better to synchronise, but still, synchronisation of wind turbines is challenging in itself until press, because there's been a new development, and this new development is coming from Sandia. Sandia have looked at that idea of the aggregation of microgeneration, but instead of using turbines per se, because we've been using basically PC fans, which are essentially HAWTs, and we've been using Savonius types, which are essentially VAWTs. Instead of looking at that, what they've been looking at is the same principle that governs a Venturi. Now, if you have a wind going through a channel like that, where you narrow the channel, it gets faster. We all know this. If you go between two buildings, it can act like a wind tunnel and pick you off your feet and slam you against the wall. So the wind gets faster. But something else happens. The pressure drops. As the pressure drops and the wind is faster, it will suck extra air in from around it to equalise that pressure. It's pretty much where an airplane gets its lift from. Now Sandia have used that idea and created a couple of airfoils, and these airfoils resemble what was used on the F1. The F1 Formula One, the Formula One car. Now of course we've been working with airfoils because we made the NACA 0015 out of some aluminium sheet. So we've had experience of making airfoils. We understand, I would think, this idea of the Venturi. So the next step would be for me to build an Aeromine that was suitable for home installation, because one of the great things about Aeromines is that's what they're designed for. They say that if they install these on the roof, they'll take up about a third of the roof space that equivalent solar would take up. So it's an awful lot more energy dense for the area that it covers, and I believe it to be something that we could actually build ourselves. And because it's so unobtrusive, then your planning permission would not be such an issue, and of course the maintenance is not such an issue because you don't have the great big motor sticking up in the air and massive propeller blades. Now the general shape of the Aeromine is like this. If you look at that, you can see it's kind of a horn-like structure, and you can see where the wind is blowing in. That wind creates the pressure and it pulls air through a ducting system, a bit like a manifold, into the cone, the exit cone. That, of course, then runs a propeller, and that propeller or fan or turbine that's now in the housing is clearly at ground level. Being in the housing there, the air is forced over the propeller, and that's what generates. And of course there is an awful lot of research. Sandia have been at this for a while. They're not just springing it on the world because it's an idea. So if you have a look at ResearchGate or have a look at Google Scholar, you'll find a lot of information about how this Aeromine can perform. Now, of course, our interest is not so much that. Our interest is, can we actually build this thing in a cost-effective way with sufficient performance to merit a bit of concentrated effort to make a few of them and stick them on your own roof and make your own generators that would be cheaper and easier to install and cheaper to run. That, of course, is what I'm very interested in. I'm very excited by this news, and I didn't know about it until it was pointed out to me, so thank you very much for pointing it out to me. Very excited by it, and clearly my very next thing is to create those airfoils, those F1 airfoils. Apparently the most commonly used airfoil for the front spoiler of a Formula 1 car is the NACA 4412. Now the F1 airfoil has this kind of shape, and we can see that it's a very different shape from the NACA 0015. It's non-symmetrical, so we have to bend an airfoil into an asymmetric shape, put the ducting in there, connect it to a manifold and connect that, probably for test purposes, to a PC fan. We do that, we should have ourselves a working Aeromine. So the next series of videos is going to be on building a working Aeromine so that we can actually test it. And I think that's really quite an interesting idea. I was so pleased that this was pointed out to me. I find it very exciting because it looks like it combines a lot of things we've already been thinking, but into a unit that has a backup of research and a lot of experimentation to actually make it work. Anyway, I thought I would raise that for you and show you what was going on, really. A quick search on the net will show you an awful lot about Aeromines. It certainly looks extremely promising, and it certainly looks like a fun project build so that we can create something that would be able to be used by us at home level to generate sufficient energy at a reasonable cost that's easy to install. They're my targets for wind generation. Anyway, I hope you enjoyed the video. Thank you very much for watching, and please remember to like and subscribe.